Well, hello, good afternoon. My name is Fernando, and today I want to explain to you the subject about current and resistance, which is the sixth theme on the Blackboard. Most likely, I'm going to make a problem so I can show you guys how to use the formulas that we have on this theme. And actually, too, I'm going to explain you a little bit about the theme and the subject. First of all, I'm going to tell you that in this subject, which is current and resistance, we talk a little, or most likely is like the same, or it has like some parts about the last subject, which was capacitance. In this case, we're going to talk about the themes that is electric current, current and density, resistivity and resistance, Ohm's law, series and partial resistors, and diodes. I chose one of the problems, which is this one. I'm going to read it for you later on. I chose one of the problems that has a little bit more of the themes that we have over here, because I'll look for the problems and I'll try to look one of them that has the complete subject that we include in this, but most likely this one is the only one that I found that is like completely with more of these things, okay? Most likely electric current, we already know because we saw a little bit on capacitance, and then we can go to this part, which is current density. I have over here a little post-it that it says that in current density we have, it's the letter for current density where we can describe the formula is going to be J. In this case, J equals the intensity, which it can be, in this case, the intensity, as I have on the post-it, it's the amperage, which it can be with an A. So this is the unit that is going to be used in intensity, and it's going to be divided by the A, which is the area that we have on the problem, okay? And then we can go to the next theme, which is, I picked these two because are the most important that we need for this problem that I described in this part. I think you cannot see the red letters, but I want to read it for you. Most likely in resistivity, we know that the formulas I have on this post-it is going to be V as volts, and it's going to be the intensity multiplying R. Okay? So in this case, what are these values? As I said before, these ones are volts. The I, it's going to be amperage, as I said on this part. And this one is going to be the resistance. Okay? So we put this post-it over here because it's a reminder about this formula. And then we have this one, which is going to be the formula for the resistance. Most likely, I'm going to put it with green. This is a formula that we're going to use maybe. It's going to be R equals rho L divided, this rho is going to be multiplying this division, okay? Divided by the area. We know that in this case, my L is going to be my length. And this one, which is rho, I know that for everyone is like weird because we never saw on the theme on the subject, this value, but this one is the resistivity. And I want to express it like this. This one is the resistivity for a specific material, okay? So in this case, for example, if we have, I don't know, in the problem we have it's going to be copper and aluminum. This one is going to be the resistivity of the copper or the aluminum, okay? Now I'm gonna take this my cell phone so I can read for you guys the problem that is the second one on the problem set unit 6. It says a copper wire has a diameter of 0.0500 centimeters. And this is the first value that we have, that we put on the beginning over here, okay? And then it says, is 3 meters long. So the copper wire is going to be this one. This is going to be where it's like on the, where it is like getting it. So it says we have this. The length is going to be 3 meters. And then it says that the density of a charge carries 8.50 times 1028 electrons in meters. Okay? This is a value that I didn't put because I made a mistake, but I'm going to put it over here. It says that it's 8.5 1028 electrons. So then it says, as shown in the figure, the copper wire is attached to an equal length of aluminum. So most likely the length for the aluminum is going to be 3 meters also. And then it says, so the aluminum wire diameter is going to be, I have it over here, it's 0.000 centimeters. So the density that the charge carries, this one is for the copper, and this one is going to be for the aluminum. It says that it's 6.02 times 1028 electrons divided by meters. Then we have the problem which says a current of 0.400 amperes flows through the copper wire. The first problem says what is a radio of the current densities in two wires, which is going to be the J, the current density for aluminum, and the current density for copper. The question B says what is the radio of the drift velocities in two wires, which is going to be BD for the copper, and it's going to be also BD for the aluminum. Okay? So I'm going to follow a little bit from the cell phone so I can solve this problem. But remember that we said that the current density in this case is going to be J I divided A. Okay? Then we can know that J is going to be minus net B, and this one is going to be my equation number 1. Okay? So in this part, we know that BD is going to be J dividing and C, which N, I'm going to put it over here, and it's number of electrons, and the electrons I'm going to mark it like minus E. So this is electrons. Okay? So now what we're going to do for the copper wire, which we remember at the beginning we said that it was 0.0500 centimeters, we got to use this formula, which is 0.0500 centimeters, and this one is going to be multiplying 1 divided 10 to the square. The answer for this problem is going to be 0.0500 times 110 squared. So we got over here the answer for this one is going to be 0.0500, the same one. This is going to be times 10 to the minus 2 meters, because this is the units that we have before. Okay, so now we know that in this case the intensity is going to be 0.400 amperage. I'm going to put this one 0.400 amperage, because that is a value that we had at the beginning over here. Okay, from now on we gotta continue. And the next step is going to check the current density, but down is going to be for the aluminum, okay? We know that the aluminum, the value is going to be over here, which is 0.0 100 centimeters. So it's going to be the same procedure. It's going to be 0.0100 centimeters. This is going to be multiplying the intensity, which is 1, divided 10 square centimeters. And the answer is going to be 0.000 times 10 to the minus 2, okay? Most likely, in this case, what we saw from the very beginning is that now we need to get the molecular weight for the copper and the aluminum, okay? We know that for the aluminum, I think it's 2.70. Yes, for the aluminum, it's going to be 2.70 times 10 to the minus 6. And then that's for the aluminum, okay? We need to put right now the, give me 1 second. Okay, so we gotta continue right now, and I'm gonna put now the number of aluminum, which is M, multiplying aluminum, and we're gonna take the value for the electrons. Here we have that is 1 electron from the formula, and it's dividing 1 atom. This is gonna be multiplying the value that we got. Okay, the value that we got at the beginning and I wrote it here. This one is for the copper and this one is for the aluminum. It's going to be, in this case, 6.23 times 10 to the 23. I'm sorry if I'm reading because I forgot a little bit about this formula. But then it's going to be multiplying, not dividing by 26.98 grams, okay? Then we continue with the molecular weight of the aluminum, which is, we know that it's 2.70 times 10 to the 6, it's not minus, I'm sorry, to the 6, and it's going to be divided by 3, okay? Then we're going to make this procedure later on so we can get the answer for this one, okay? Now what we're going to make, it's the same, but now it's going to be for the copper, which is MCU, and the same. The first part is exactly the same, 1 electron, 1 atom. Now we got the same 6.23 times 10.3. This is going to be divided by 63.55 grams, which is from the values that we got at the beginning. And this one is going to be multiplying for the molecular weight from the copper, which is 8.94 times 10 to the 6. For the copper, it's going to be 8.94 times 10 to the 6. So we're going to write it over here. 8.94 times 10 to the 6. This divided by meters cubes. Okay? We continue, and now we're going to take the values about this formula. So give me 1 second. It's going to be 6.023 divided by 26.